So picture this for a second.
Yeah.
It is like 4:55 p.m. on a Friday.
Oh, the absolute danger zone.
Right. The worst time to do anything. You are staring at your terminal, getting ready to deploy this this critical update to your company's cloud infrastructure.
Yeah, you just want to go home.
Exactly. So you type Terraform apply, you hit enter, and you just watch the logs scroll by. And, at first, the core network builds perfectly. The new servers spin up without a hitch.
Sounds like a dream.
I mean, the architecture is flawless. You are literally already thinking about dinner at this point. Yes, then the automated deployment suddenly just freezes.
Yeah, you're watching this tiny obscure bash script that was supposed to configure a database connection or something, and it just hangs there.
Just sitting there doing nothing. 5 seconds go by, then 30 seconds, then boom. The dreaded timeout error flashes on your screen in bright red text.
And like normally you just fix the script and try again, right?
Right. But instead of letting you do that, Terraform marks your brand new, perfectly healthy server as this corrupted biohazard. It panics, and it prepares to just completely vaporize it from existence on your next deployment.
It is incredibly frustrating.
Welcome to the deep dive. Today, we are taking a stack of sources straight from the official HashiCorp documentation and the Terraform Associate 003 exam materials. And we are unpacking a topic that is the absolute definition of a messy reality.
Terraform Provisioners.
Terraform Provisioners.
Yeah, because we usually think of infrastructure as code, as this pristine mathematical blueprint, right? You declare what you want, and the system builds it exactly as specified.
But Provisioners kind of ruin that.
They break that illusion completely. They are essentially the rogue variable in your automated assembly line.
I want to talk directly to you, the listener, for a second here. Because whether you are, cramming for that Associate 003 certification, or you're just trying to keep your own automated pipelines from exploding on a Friday afternoon, provisioners are a topic you will inevitably stumble across.
Oh, absolutely. It's guaranteed.
And our sources use this metaphor that I think is just absolutely perfect. They say provisioners are the duct tape of Terraform.
The duct tape. I love that.
Right, because they fix the weird edge case things that nothing else can quite reach. But, if your entire cloud architecture is held together by them...
something has gone terribly, terribly wrong.
Exactly. Okay, let's unpack this. What exactly is this duct tape, and, why is HashiCorp warning us to stay away from it?
Well, to understand the warning, we really have to understand the mechanism first. At their core, provisioners are custom scripts or specific actions that Terraform runs on your resources at very specific times in their life cycle.
So it's not standard Terraform behavior.
Right. You use them to step outside of Terraform's standard sandbox. Instead of just creating a server from the outside, you are trying to reach into that server and make it do something immediately after it's born or just before it dies.
Okay. And the documentation breaks this duct tape down into 3 distinct flavors. Let's look at the first one, which is local-exec. Now, local is a word that causes a ton of confusion in cloud computing.
It absolutely does, yeah, because it sounds like it means the local server you just built.
Right.
But in this context, local-exec means running a command on the actual machine that is running Terraform itself. It never touches the newly created cloud resource directly.
Oh, okay. So if I'm running Terraform manually on my laptop, local-exec opens up a background terminal on my laptop and runs a command right there.
Precisely. But, in the real world, we rarely run Terraform from our laptops.
Yeah, usually it's in a CI/CD pipeline, right? Like GitHub Actions or Jenkins.
Exactly. So in that case, local-exec is running on that specific GitHub runner server. You are executing a local script to kind of complement your infrastructure creation.
Give me an example of that from the exam materials.
Sure. A classic scenario would be using Terraform to create a brand new EC2 instance in AWS. And the very second that instance is physically up and running, you use a local-exec provisioner to trigger an external tool.
Like Ansible.
Like an Ansible playbook. From your deployment machine, you just tell it to go find that new server and configure it.
Got it. Which brings us to the second flavor, which does the exact opposite, right? Remote-exec.
Yeah, remote-exec. This is Terraform logging directly into the newly created resource and running commands on its command line.
So actually reaching inside the new server. The sources mentioned using SSH for Linux servers, or WinRM for Windows servers.
Yeah, WinRM is basically the remote management equivalent there. You are effectively forcing Terraform to act like a human system administrator. It reaches through the internet, logs in, and literally types on the keyboard of that new machine.
That's a great visual. And the third flavor goes hand in hand with this, which is the file provisioner.
Right. That just copies files or, entire directories from your Terraform machine over to that remote resource.
Okay, I'm going to push back on the whole HashiCorp philosophy here for a second.
Oh, here we go.
No, seriously. I am looking at these three options, and honestly, this seems incredibly convenient.
It does seem that way at first.
Right. Isn't logging into a server to configure it exactly what we need to do in the real world? If I'm spinning up a web server, why shouldn't I just use remote-exec to run a quick update command, install Apache, and then use the file provisioner to drop my HTML files in there? It feels like a perfect one-stop shop.
I get it. It feels like a one-stop shop until you try to scale it, or until you try to rely on it in a professional automated environment.
Okay, why? What breaks?
What's fascinating here is that the illusion of convenience totally shatters the moment you look at the underlying mechanics. To use remote-exec or the file provisioner, you have to establish a connection.
Like a network connection.
Yes.
Yeah.
In Terraform, that means explicitly writing a connection block in your code.
Oh, I see. Which means I have to give Terraform the SSH keys, the passwords, all the network routing instructions.
Exactly. You are suddenly hard-coding, or at least passing around highly sensitive credentials just to make a bash script run.
Yeah, security teams love that.
Right, but honestly, worse than the credential management is the network reality.
Yeah.
You have to ensure the network actually allows inbound SSH access from wherever Terraform is running.
Oh, wow. Yeah. If you are operating in a highly secure enterprise environment, your security team will immediately block your deployment.
Instantly. If you ask them to open port 22 to your CI/CD pipeline just so Terraform can run a script, forget it.
They would shut that down in a heartbeat. Port 22 is a massive attack vector.
It is, but even beyond the security nightmare, it just makes your automated pipelines incredibly fragile.
Because of the connection itself.
Yeah. You are relying on the open internet or, some complex VPN routing to maintain a continuous, uninterrupted connection while a script runs.
And networks are never perfect.
Never.
Ugh.
A brief network blip, a firewall rule updating in the background, or even just the operating system booting up a few seconds slower than expected.
And your SSH connection just times out.
Exactly. And because of that tiny network hiccup, your entire multi-million-dollar infrastructure deployment fails. Even though the actual servers and databases were built perfectly by AWS or Azure.
That is wild. The fragility is basically built into the method itself.
Which is precisely why relying on an active, persistent connection from your provisioning tool is just a recipe for disaster.
Okay, so since these scripts are so prone to failing on the way up, it kind of makes you wonder what happens when we try to tear infrastructure down. Like, can we use this duct tape to pack up a server safely? Or is it just as fragile?
That introduces the concept of lifecycle timing.
Right.
By default, provisioners are what we call creation time provisioners. They run exactly once the very moment the resource is born.
Right.
But you can add a specific argument inside the block.
The when equals destroy argument, right?
Yes, when destroy. That flips the behavior entirely. It becomes a destroy time provisioner, which runs just before a resource is permanently deleted.
It's like a tenant moving out of an apartment.
Oh, I like that.
Yeah, creation time is moving the furniture in. You get the keys, you paint the walls, you set up the couch. That only happens once. But destroy time is cleaning the apartment before handing the keys back to the landlord.
Right, you have to scrub the floors and patch the holes before the lease is officially terminated. That visual makes the timing perfectly clear. You are preparing the broader environment for the departure of that resource.
But give me a concrete technical scenario here. If I am deleting a server just to save money, I'm deleting it. Why do I care what it does on its way out the door?
Let's look at a highly critical real-world scenario that the exam loves. Graceful cluster node removal.
Okay.
Imagine you have a massive, highly available database cluster. Multiple servers constantly talking to each other, sharing a heavy workload, and replicating data in real time.
So they are all holding onto the same rope in a giant game of tug-of-war.
Exactly. If you just tell Terraform to delete one of those nodes, Terraform sends a ruthless API call to your cloud provider.
And the server is just instantly vaporized.
Vaporized. But the rest of the database cluster has no idea what just happened. They were streaming data to that node a millisecond ago.
Oh, man.
Suddenly, the connection is violently severed. The remaining nodes panic. They start throwing errors, dropping customer transactions, and just scrambling to recover data they think was lost in a catastrophic hardware failure.
Wow. You essentially induce a false outage just by trying to scale down your infrastructure gracefully.
But if you implement a destroy time provisioner, You change the whole dynamic. Just before Terraform vaporizes the server, it pauses. It runs a remote-exec script on that specific node that broadcasts a message.
Like, hey, cluster, I'm leaving.
Yeah, literally. Hey, cluster, I am voluntarily leaving. Please stop sending me traffic and rebalance the data. The cluster adjusts calmly, and once the script finishes and the node is safely isolated, then Terraform proceeds to actually destroy the underlying infrastructure.
Okay, that makes complete sense.
Yeah.
You're moving the furniture out carefully instead of just blowing up the building with everything still inside.
Ex-
But, moving furniture sounds great until someone drops a couch down the stairs.
Oh, and they will.
Right. Here's where it gets really interesting. What actually happens when the duct tape fails? Because as we discussed earlier, scripts fail constantly. A typo, a missing software dependency, a random network timeout.
Understanding failure states is critical here, especially if you are taking the associate exam. You can configure how Terraform reacts using the on-failure setting.
Right, and you have two options there, right?
Yeah, continue or fail. So continue means the script errors out, but Terraform just shrugs, ignores the error, and happily keeps building the rest of your infrastructure.
That sounds dangerous. I mean, I can see the appeal if the script isn't mission critical, but still.
It is dangerous, but the default behavior is fail. And the default behavior is where the true danger lies.
Wait, why?
Because if a creation time provisioner fails, the entire Terraform apply process instantly stops and throws an error.
But wait, let's walk through the logic there. If it is a creation time provisioner, that means it runs immediately after the resource is created.
Yes.
So the server itself already exists. AWS or Azure successfully built it, and they are actively charging you money for it.
You've hit on the core problem. The resource physically exists in the real world, but the configuration script that was supposed to make it usable failed halfway through.
So you have a server that is basically half-baked. It's breathing, but its internal configuration is entirely unknown. What does Terraform do with a half-baked server?
It marks the state of that resource as tainted.
Tainted. That sounds like a biohazard warning.
In the realm of infrastructure as code, it is a biohazard warning. Tainted means Terraform fundamentally no longer trusts that resource.
Even though it built it.
Even though it built it, it acknowledges the server exists, but because the creation sequence didn't finish, Terraform considers it corrupted.
Did you fix it?
You can manually intervene. Historically, people use the Terraform taint command to manually mark things as degraded, though, modern best practice is to use the light replace flag during your next deploy. Conversely, if you logged into that half-baked server yourself, fixed the broken configuration manually, and wanted to keep it, you could use a sort of hazmat suit command like Terraform untaint.
Basically telling Terraform, I fixed it, remove the biohazard label.
Exactly.
Okay, listeners, pay close attention here because this sets up the ultimate trap scenario from the exam.
Oh, this is a classic.
You run your deployment, a server is built, but the provisioner script fails. The server is now marked as a tainted biohazard in your state file. You realize you made a simple typo in your bash script. So you fix the typo in your Terraform code. What happens when you run Terraform apply again?
Well, human intuition tells us that Terraform should just try to run the script again.
Right. Pick up where it left off, run the fixed script, and finish the job. It seems like the most efficient way to handle it.
But Terraform is built on the philosophy of immutable infrastructure. It does not try to fix corrupted things. If a resource is tainted, Terraform's reaction on that next apply is to completely destroy the tainted server and build a brand new one from scratch.
Wow. It doesn't even attempt a salvage operation. It just nukes the resource from orbit.
It has to, because Terraform is blind to the actions of your script. It tracks cloud resources, right?
Yeah.
IP addresses, disk sizes, security groups.
Things the cloud provider tells it about.
Yes. It cannot track what an arbitrary bash script did inside the operating system. Did your broken script install half a software package? Did it create corrupted configuration files? Terraform has no idea.
That makes sense.
So the only mathematically safe way to guarantee your environment matches your code is to completely wipe the slate clean and start over.
But that is an incredibly harsh penalty for, like, a network timeout. If Terraform's reaction to a failed provisioner is to literally burn the house down and rebuild it, maybe we shouldn't be writing provisioners in the first place.
And you have just arrived at HashiCorp's official stance. They explicitly designate provisioners as a last resort.
A last resort.
Yeah, the documentation urges you to find literally any other solution before reaching for the duct tape.
So what does this all mean? If provisioners are the last resort, what are the primary resorts? How do we actually configure servers without breaking our pipelines? Like if I just need to install a simple package on boot and remote-exec is off the table, what is the alternative?
The first, and honestly most common alternative, is leveraging cloud init or user data.
Okay, how does that work?
Every major cloud provider has a mechanism to pass a script directly to the virtual machine's hypervisor during creation. When the server boots up for the very first time, it reads that script and runs it locally itself.
Oh, so that completely eliminates the SSH problem. Terraform isn't trying to connect over the open internet. It just hands the instructions to the cloud provider, and the server configures itself from the inside out.
Exactly. It is infinitely more reliable.
Okay, but what if I am in that strict enterprise environment we talked about earlier? My security team refuses to let me use user data for highly sensitive scripts, and they have permanently blocked port 22. How do I configure a fleet of servers securely without inbound access?
That is where you look at something like AWS Systems Manager, or SSM.
SSM.
SSM solves the inbound port problem by completely reversing the flow of communication. Instead of Terraform pushing commands in via SSH, an SSM agent running on the server reaches out to the AWS API and pulls down its instructions.
Ah, so the server is essentially asking, hey, do you have any work for me? Over a secure, standard, outbound HTTPS connection.
Yes, security teams absolutely love it because there are no open inbound ports, and you manage the configuration through native, heavily audited cloud tools.
That's brilliant. Let's tackle the bottleneck problem next, though, because even if I use SSM or Cloud Init, if I'm installing a massive application that takes, 20 minutes to compile, my deployment pipeline still crawls to a halt.
Sure.
I don't want to sit there watching a progress bar every time I scale up my infrastructure.
To eliminate deployment time bottlenecks, you shift the work to the left using a tool like Packer.
Packer, another HashiCorp tool, right?
Yep. Packer is designed specifically for building machine images. Instead of creating a blank server and installing software on the fly, you use Packer days in advance to create a custom, pre-baked hard drive image.
So you do the heavy lifting early.
Right. You install Apache, your...
Terraform. It asks the cloud provider to boot up that pre-made image.
And the server boots up fully configured in a matter of seconds. Zero installation delays during your actual deployment.
That is incredibly powerful. And what about ongoing, really complex setups across hundreds of servers?
That is the domain of dedicated configuration management tools like Ansible, Chef, or Puppet.
Right, because Terraform isn't really built for that.
No, Terraform is an infrastructure provisioning tool. It builds the house. Ansible is a configuration management tool. It paints the walls and arranges the furniture.
Okay, I have to play devil's advocate one last time here.
Go for it.
I hear you. Packer eliminates bottlenecks. SSM fixes security. Ansible handles complex logic. But, they all take time to learn.
They do.
They require setting up new repositories, learning new syntaxes, building entirely new automation pipelines. A remote-exec provisioner is just a tiny block of code I can add to my Terraform file in literally 5 seconds. When the pressure is on, why shouldn't I just take the shortcut?
Because that shortcut guarantees long-term fragility. When you rely on provisioners, you actively break the core benefits of Terraform.
Because of the state file.
Yes. As we established, Terraform's state file goes blind.
Right.
You lose visibility into what is actually running on your servers. You introduce pipeline bottlenecks that slow down your entire engineering team.
So you're trading a tiny bit of upfront learning for a massive long-term headache.
You trade a small amount of learning for an architecture that might collapse every time the network blips. Which brings us to the ultimate golden rule from the source material.
Let's hear it.
If you find yourself writing a provisioner block in your Terraform code, first ask yourself why 3 times.
Ask why 3 times. I love the psychological trick there.
It's super effective.
Why am I doing this? Because I need to install Nginx. Why can't I use user data? Because I don't know the syntax. Why don't I just take 20 minutes to read the documentation?
Exactly.
It forces you to confront the reality that the shortcut is usually just a knowledge gap.
It forces you to challenge your own assumptions before you reach for the duct tape and permanently weaken your infrastructure.
All right, let's quickly recap our journey through the messy reality of Terraform Provisioners. We've learned that they are the duct tape of infrastructure as code. They let you run scripts locally, remotely over fragile connections or copy files.
Yep.
They can run on creation, or they can act like a tenant cleaning up an apartment by running on destroy to, gracefully remove a node from a cluster.
But the risks almost always outweigh the rewards.
Because if a creation provisioner fails, You're stuck with a tainted biohazard resource. And Terraform won't try to salvage it. It will completely nuke it from orbit and start over on your next apply.
Which is painful.
Which is why you should always look for alternatives. Use Cloud Init for simple boot scripts, SSM for secure agent polling, Packer for pre-baking lightning-fast images, or Ansible for dedicated configuration.
If we connect this to the bigger picture, it really highlights a fundamental tension in how we manage modern cloud environments.
How so?
Terraform is fundamentally designed to be declarative. You declare the final state you want. I need 3 servers and a load balancer. And Terraform handles the complex math to make it a reality. You don't micromanage the steps.
Right, you just provide the blueprint and trust the system to build it.
But provisioners are inherently imperative. They are manual, step-by-step checklists. Log in, run this update, wait 10 seconds, copy this file.
Oh, I see.
This raises an important question. Could the real reason provisioners are so notoriously fragile be that they force an imperative square peg into a declarative round hole?
Wow.
By relying on them, are we actively breaking the very philosophy of automation that makes infrastructure as code so powerful in the first place?
Oh, that is a fantastic thought to leave off on. Are we breaking the foundational philosophy of our tools just to save 20 minutes of learning? Something to definitely mull over the next time you are staring at a blinking cursor at 4:55 p.m., tempted to write a remote-exec block. Good luck to everyone studying for the Terraform Associate exam. And remember, let the system do its job. Step away from the duct tape.